Next integral, I equals the integral of 3 on x squared plus 2x plus 2. So we have a fraction, it's a polynomial fraction. The bottom is a quadratic, it's not a perfect square. It doesn't really factorise very nicely either. So we look at this and we think, well, we're puzzled, well, what do we do with it? One of the things we can do is we can try and complete the square or turn this into a perfect square somehow. And so with a little bit of observation, a little bit of experience, that's what it often takes with these, is just experience. We can do a little bit of manipulation and turn it into something that we can work with. So x squared plus 2x plus 2 is not that far away from x squared plus 2x plus 1, and that is a perfect square. So I'm going to write it as x squared plus 2x plus 1 plus 1. So, like that, dx. And by doing that, I can now write the integral as 3 over... Now, x squared plus 2x plus 1 is a perfect square. I can write it as x plus 1 squared plus 1 dx. And this is now starting to look familiar, because if you have a look through your table of integrals, you'll see that this is very closely related to the inverse tan integral. So we just need to do a little bit of bashing into shape. X plus 1 doesn't, well, its derivative is just 1, so I don't need to do anything special here. Whether you've got an x or whether you've got an x plus 1 isn't going to make a big difference in our answer, because the derivative of x plus 1 is just 1. So I can just pull that 3 out. And then the last part of it is to look at the table of integrals, look at well, what's the thing that looks the most like this. It's an inverse trig, inverse tan, and so my answer is going to be, and we're done.